part of the 3 decades, but I can explain what happened during the last 15 years. That is half of the time. And so this is the presentation outline. I have about 5 modules, out of which one is for sure very interesting, the last one, which I'll explain to you when we come there. But I'll start with what we do at IIT Tirupati, my group. So we call ourselves MapSmart, Materials for Sustainability, Asset Management, and Performance Monitoring of Smart Infrastructure. We work on asphalt, we work on concrete. It's all about pavements, materials, sustainability, and all the buzzwords that we have. But we also do a lot of work on waste to wealth, circular economy. We've also done a lot of work on LCA, and I being involved with Resources Conservation and Recycling Journal, and possibly the only from India. We also have been working on several aspects of circularity. Okay, and we do a lot of work with plastic wastes, rubber, composite wastes, and many, many other aspects. And we also have developed our own product for concrete pavements, pervious concrete, some of you might be familiar, for groundwater recharge and urban heat island mitigation things. And India is very keen on developing its own design guideline, which I'll explain later. So we have this cost, effect, and need relationship, as you're all familiar. So that's an integrated life cycle sustainable development goals, pertinent issues of infrastructure development. So we work on resource consumption, resourceful consumption, I should say, solid waste, construction demolition, and end-of-life tires. That has been my bread for the last several years. And we also have been working with Department of Defense in India. We call the DRDO, Defense Research and Development Organization, where they have a lot of composite wastes, including carbon fiber and glass fiber reinforced polymers, which have been lying as landfill. So there have been a lot of landfill issues. So when we went there, we said we'll be happy to use those and recycle those as part of pavements. So that is another thing that we have been doing. So as part of 11 or 12 hours that we have coming from the SDG, so we have been working on all of these, and we have developed over 24 products in-house, all the way starting from plastic to plastic asphalt, or rubber to rubberized asphalt, both in terms of coating plastic and rubber getting coated with plastic. And we also have been working on bio-based binders, bio-based asphalt, which one of my students actually spoke yesterday. She'll also be speaking about the industrial waste products such as pond ash, fly ash, and many other waste products that are being utilized. And then we have also been working on the replacement of aggregates with tire, rubber-based, which will be one other presentation sometime today. So all of these are waste to wealth products that we have developed, and we also work on this integrated mechanistic roadway designs as part of the design guidelines. So we are all familiar about the material uncertainties, but they have not been integrated very much with the actual vehicular traffic or vehicular types, so the axle distribution that are there. So we still use the e-cell concept. Some of you might be familiar with this, the 80 kilonewton or the 8-ton, 18 kips load that is being integrated into the mechanistic design guideline. So we are now moving away from that and becoming more on the mechanistic, where we use the variable vehicle and variable traffic, not the fixed traffic or the fixed vehicle approaches. And the other part is something that is more interesting, is we are very familiar with the structural aspects, but we don't talk about the emissions, so that needs an integration. So that we call the integrated life cycle approach, sustainable transportation infrastructure systems. So I work on this as well, where we also have the 3 aspects: environment, economy, and human health. We also work on the electric vehicles as part of our group. And we have a large project coming from the Ministry of Road Transport. We're very thankful to them, about $1.5 million project where we are building an accelerated testing facility. It'll be first of its kind in the world, where we are using 2 real trucks fully loaded in a circular track that will run anywhere between 20 and 100 kilometers per hour fully loaded. And we will be able to get the performance in an accelerated mode and also have some savings of the cost and time. And this is also a facility that will be studying vehicle noise, vibration, and harshness. So that is other aspect coming from the mechanical systems. And so here is a picture of the facilities. So this is a facility that's the largest lab that we have in the country, 50,000 square feet, 5,000 square meter. You see a drone picture here. It was being built. Now it's fully built. It's a 5.5 meter wide track, 96 meter perimeter. So it's a circular track, something like the Asher road test that was performed way back in 1960s. But this is a smaller loop, but still capable of running 2 real trucks, as you see here. Okay, and I'll just play this, it's not very difficult to understand, so it keeps running in a circular fashion at varying speeds, and it's open to environment, so it is a real-time center for real-time monitoring. And these were all designed by us in-house, so nothing was imported, so it was a make in India as we keep doing. Okay. And this is our visions from the group. So we talk about linear economy today. Most of us are familiar with this. Recover and recycle, these are the 2 R's that are very familiar to all of us, linear. We are now into the cusp of semi-circular. That is what we talk, remanufacture and reuse. And then we are moving towards rethink and reduce. That's a fully circular economy, that what we envisage across the world. Okay? And that is where we come into that holistic, integrated approach of sustainable pavement designs or infrastructure, including recyclability, remanufacture, and so forth. So these are the potential thrust areas for those who are interested in approaching research from fundamental principles and moving into the application, right? So there is a color coding to this, okay? There is this green, which is a very, very generic topics. And then we have this black color that is linear. That is what we do. All of us do this. Then we move into the semicircular, which is in blue color. Then we move into the maroon or red, whatever that you call it. That is a fully circular economy. So if you would like to take some of the thrust areas from here and work on these, that will be interesting for you for sure, anywhere in the world. And that is what this LCCA, LCA, and a lot of others that spoke yesterday and today, including from various other countries. So I'll just move on to the next module, the experiences that have undergone in India. The early years of AR technology, about 30 years, 95 through 2015, how they started the trials. So I got some information from the government and the research institutions that have endorsed this product. It all began, so it's not written in the slide, but it all began as a 5% rubber by weight of the asphalt binder. And they started to use the truck tires instead of the automobile tires. That is what they've been using for a long time now. And the refineries moved from this 5% to about 8 to 10%. Today they run about 12% rubber by weight of the asphalt cement. So it's still not the ASTM standard. As the ASTM says, the asphalt, the binder that is modified with crumb rubber will be called asphalt rubber only if the rubber content is minimum of 15%. So India doesn't still use this. So, but we were testimony, we provided testimony very recently, and I'll talk about this in a second. So in 2000, they sent out a circular that the government can start using or reusing the crumb rubber in manufacturing crumb rubber modified bitumen. So they called it CRMB in India, and it was introduced by Tina Rubber and Infrastructure way back in late 90s. And between 95 and 2017, they built about 49 test tracks across India and validated by various research institutions, including us, where I belong to this IIT Tirupati, and the other institutions, including the CSIR lab, which is based in Delhi. And they released another circular in 2023, which I'll talk about in the next slide, which said, yes, you can start reusing, recycling more than 5% rubber, not just trucks, but also the automobile tires. And 2025 was much more interesting, which I'll share with you in the next slide later on. And then 2000 to 2010 adopted by major road contractors, including in the airports. Okay, right now, more than 5 million tons of CRMB has been used across 300,000 lane kilometers in India, and for several types of traffic, including local, arterials, and major roads. Okay, and this is the circular that was released in 2023. Why I'm sharing this with you? Because it is so tough, and I was speaking with some of you yesterday. How do you actually bring in the legislation by the government to start using these kinds of unconventional products? It was very tight, okay, it was tough. You see here, it took about 20 plus years before the directive came in from the government. And it says to minimize separation issue, modified bitumen, it also included polymer and CRMB or the natural rubber modified bitumen. It can be procured from domestic sources. It used to be procured from elsewhere and then was being reused, but now they have their own standard operating procedure, and there is a guideline to understand the binder properties, including viscosity and others. This was released in 2023 after I got into the panel in 2015. It took us some time to convince. And then later on in 2025, so they called me to provide a testimony by the Ministry of Environment, Forests and Climate Change. That was coming from the recommendation on the environment and sustainability perspective. So that is where the ministry moved from the conventional approach to the sustainable development goals. So what we mandated was 3 to 5% utilization of CR of the total amount of bitumen production over the next 3 years. So that is what is the minimum of 3 to 5% of any projects that come in from the government side. And you can read those recommendations here. I know it's too small, but they say that between now and 2029, they can move from 3 to 5%. And we provided all kinds of evidences, including the ASTM, when we said the minimum percentage of rubber should be 15. And that is how the asphalt rubber comes into picture. Until now, it was not called asphalt rubber. It was called crumb rubber modified. So when you say CRMB, it could be 2%, 3%, 5%. But now it's real AR that they have to be using 15% by weight of asphalt cement. That is what is the directive coming from the government. And it comes all the way from the Ministry of Road Transport in conjunction with Ministry of Environment, Forest and Climate Change. So both of them have acted together on this. Then comes the decade of innovation. So we move into this next module where I was very much involved in the last 10 years. We developed our own specification coming from the government on asphalt rubber gap graded sections, something that you're all familiar with. And we also developed our own product that could be something similar to RAR, okay, which I'll share with you in the next few slides. So these are the two state-of-the-art review papers, are very highly cited, wherein Dr. George Souza and Mr. George Way were involved in one of them, where we talked about the state-of-the-art practices, research review, and the current practices across the world, covering at least 300 papers. So I can share this paper with you, or if you have subscription, please go download this from the Road Materials and Pavement Design Journal. The other one talks about how recyclability, including increase of the percentage of rubber from 15 or 20% to 60% rubber. So that is the other review paper that you see here, and it's also published in Resources Conservation Recycling, very high impact journal, and it talks about increasing the rubber content from just mere 15 or 20% to 60 or 65%. Okay, so that is the other research paper. You can read this, download, or please let me know, I'll share this with you. Both of them are now successful faculty across. So I'll just share one anecdotal experience from the Government of India Ministry of Science and Technology project that we have had in the past. We established globally accepted superpave mixture design for asphalt rubber gap. It was developed in-house. We didn't borrow anything, so we developed our own gradation, our own crumb rubber and aggregate gradations, and then the binder content, and then the entire procedure of understanding the mixture designs or the binder properties. So that was also standard protocol. In fact, this was first time that superpave was used fully in coming up with an asphalt rubber gap graded mixture. So this is what is the formula, and it's being shared here with you, okay? And we have 5 to 7% binder content, okay, a little bit higher, obviously, to accommodate rubber. And one thing I want to go back and tell you, even now, as you saw in the previous session, they still use about 4 or 5% binder, even including rubber in the Middle East. So that was the actual thing even in India for the last 20, 25 years, where they still used dense graded with rubber with no space available for rubber. And that doesn't work. So it was called an unsuccessful product. So we said, no, you need to have more gaps, more openness in the gradation that can accommodate rubber and can also provide you that performance. Right? And you can also increase the amount of rubber in the gradation. So you see here, it's a 20% rubber that we used by weight of the asphalt cement, super pave, fully done, and air voids on the lower side, but that could accommodate all kinds of gradations here. It's a published document in a reputed journal that I can share with you later. And VMA, that's the voids in the mineral aggregates, was very high, as you see here. And we also built a test section as part of this, and it lasted for 4 years with no signs of cracking and no signs of rotting whatsoever. It was a very highly trafficked state highway. And it was also a location where there was huge rainfall, okay? Second highest rainfall in the country after the highest rainfall in the world. So we get anywhere between 3,000 and 4,000 millimeter annual rainfall there. So we didn't change any of the lower layers, including the binder or the base courses. We just changed the topmost layer, asphalt rubber gap, that was about 40 millimeter section. So we built on the top of several layers that were dense graded, macadams and the granular base courses. And we're very clear that we should not be using a vibratory roller, because we're a very thin section, so we don't damage the pavement system before it even gets into the traffic mode. So it was built in 2017, and it was a state highway. It was a 2-lane undivided, as you see here, and we didn't use a vibratory roller, but we just use a cosmetic static steel wheel that was sufficient. Of course, we didn't use the pneumatic tire because it could start attracting more binder and the aggregate. Okay, and then we compacted an additional 2 passes to make sure that there is sufficient compaction and the traffic that can come in. Can you see here the texture of that from very close? And the control section had all potholes. We only built 250 meter, and as my senior colleague Alex mentioned yesterday, they also were only allowed to pave a very small section. That's what we had in the beginning. This was a fully asphalt rubber section, as I mentioned here, 20% rubber. Okay, and 2018 still survived, 19, and then they later on had to rip it off because the state highway got converted to national highway. So we are redesigning this with a new project on a 6-lane highway. Very soon that will be seen. And then, so there are more publications out of this. So we developed our own models, the design guideline for asphalt rubber, and so forth. Then we moved on to the modified asphalt rubber. I mentioned this to you. We increased the rubber content from mere 15-20% to 60%. Now you see here 46% rubber with lime that binds. Okay, and we call this mark pave modified asphalt rubber, green pavement with increased rubber content. And we have an OMT, the organomontmorillonite. It's a nano clay that's abundantly available in nature. So we started to use this to activate and charge the rubber particles, a priori being blended with aggregate and binders. So that is what we have here. It's a published document. I can share this with you later on. And it is now being used as part of one new project. And it's still a product that could be used as a semi-dry, exactly like the way that RAR can be used. It was developed in-house, and it's a dry to semi-dry. You straight use this as a replacement of fillers. And we could see the fatigue life going anywhere between 3 and 25 times better than conventional asphalt or even the asphalt rubber mixtures. Okay, and the next thing that we did was with the government, again, we came up with another project, extended the situation with industrial waste. Now we wanted to start using not just nano clay, but the industrial products such such as pond ash, fly ash, granulated blast furnace slag, or many other industrial waste to make sure that we have more wastes that can be developed into wealthy products. And this will be part of one of my other students' presentations today or tomorrow, where she'll be presenting on the thermochemical properties and how it was developed as part of this project. So the Ministry of Environment and Forest and Climate Change and Ministry of Oil, Natural Gas and Petroleum, they came in touch with us and they said we need to encapsulate these products mainly because there is this storage issue. And I'm sure some of you are familiar with this. Asphalt rubber cannot be stored for more than 4 to 5 hours. So we said we'll come up with another product that could be encapsulated into capsules. And we have found the shelf life to be anywhere between 8 and 40 years. You can store these products into capsules for more than 8 years. Okay, we have a shelf life study that we have undergone, and we have undertaken that, and it works very well. So it's part of that study. Many others. And then when I was at Arizona State, when I was introduced to this product, Dr. Kalush and Dr. Golden, they were part of the School of Sustainability, and Dr. White, who was also part of that team. So we actually came up with a study on understanding the life cycle analysis. This was possibly first of its kind study in the world. It was way back in 2007-8 when this was my class term paper, okay, and it developed as a full-fledged journal paper, very highly cited paper. Even to this day, a lot of people still inquire about this. And what we found here, you see, it's very interesting. About 15 years ago, when you talk about asphalt rubber, 50% of kg CO2 emissions reduced when you compare that with the HMA of the same thickness and same materials. And also we linked this with the service life. So it was both in life cycle analysis and life cycle cost, but in a very crude sense. We didn't have those tools those days. I'm talking about 2007, 8, 9, when the SEMA Pro and others were still being developed, EcoInvent still being developed. But we could still find this as part of that study. And then later on in 2023, we came up with another study. It's still an ongoing study with Ministry of Environment, Forests, and with industry partners, real data that is being studied on the circularity. We see here it's about 3 times still embodied energy lowered, right, with rubberized asphalt there, and GHG emissions about 100 times lower. And this we have expanded to the other 18 indicators. Some of you were asking yesterday how many indicators. So there are 18 indicators, and we have developed our own Excel spreadsheet. You don't have to depend on any more software tools such as SEMA Pro. You can use our tool to understand the 18 indicators very much. Okay, and it's a published document. I can share that later on. I didn't present it here. It's still under review by the ministry. So where do we go now? What is the next position in India? Where do we go with the asphalt rubber technology? So it's, again, coming back to this plastic rubber. One of our students will be presenting this, how we are utilizing plastic that is being coated with rubber and blend it with asphalt to get aggregates out of this. So we are trying to use these plastic rubber aggregates. We call that modified tire derived aggregates. It's not a new concept, but plastic being introduced is new. Okay. Why are we using plastic and rubber together? Plastic by itself becomes very stiff, and it'll start to be brittle, so it'll start to have shrinkage cracks, basically. Rubber being a very resilient product, you're all familiar with this, so we have started to use plastic and rubber in combination. It's a good combo, and we have found that this could be used as part of sub-base and base courses. It's a published document, as you see here, and we have also put a section. We have started to use pothole patching with this, not even a single crack or rut in the last few months that we have placed a test section recently. And more details from the student here. So we have created all kinds of different types of combinations: 10% rubber, 15% rubber, 5% plastic, 10% plastic, and many combinations. We have also started to use plastic coating the rubber, rubber coating the plastic. We have used both combinations there, and it works very well. We have studied the chemical analyses. We've done that, and then we have also done a pothole patching using this product with plastic and rubber. It works very well. And the the ministry is very keen on using this across India, so we've got a large project to use this from the ministry. And then the key takeaway is here, you see here, 60% tired year aggregates, which is rubber-based. We have 15% asphalt binder, 10% recycled plastics, and hydraulic lime and compatibilizer. That is what is the combination here. We can share more details if you wish. For every 100 tons of this product, 15 tons of asphalt binder will be replaced by waste plastic. That is a significant amount, okay, including in cost savings, and it's a recyclable product there. And the next thing is the fly ash modified, which is futuristic. As I mentioned, this industrial waste products. You can start using this fly ash, pond ash, or blast furnace slags, or many other products that have been very, very compatible with asphalt rubber. And we can charge these with rubber a priori being blended with aggregates. So that makes it a very strong mix. And we've used this, again, key takeaway, 30 tons of modified asphalt rubber with this pond ash, fly ash, 18 tons of crumb rubber, 2.4 tons of industrial waste will be utilized in construction 1 lane kilometer. Very, very sustainable product there. And then we have also started to use the bio-based rubber products that you saw that yesterday, one of the presentations that was mentioned, and rice husk ash, bentonite, and then we've also started to use the fly ash. So all of these are coming from the circular economy perspective. Again, 2.1 tons of fly ash, 3.15 tons of rice husk can become a zeolite, and that becomes the war mix asphalt additive. So rubber, the question that has always been there with asphalt rubber, the production temperatures can raise between 10 and 20 degree additional. So we can start using war mix asphalt additives with asphalt rubber that can lower it down by 15 or 20 degrees C. And then we have got a large grant now. Recently, this is my last slide before I close down. So this is the futuristic perspective coming from India. We have a large project, $300,000 grant from the Ministry of Road Transport, National Highways, where we'll be constructing 25 sections across various climatic zones, various traffic and climatic conditions across India, including in the Himalayas. Some of you might be familiar. That goes to -40 in the winter. So we are going to use asphalt rubber in cold climates in India as well, and very high temperature zones such as 80 degrees C pavement temperatures, and tropical climates. We have all kinds in India, very diverse climatic conditions. So we're going to use all of these in varying areas and come up with guidelines for asphalt rubber pavements in India. And we're creating a master database, including performance models exclusive for asphalt rubber, and come up with a design software which we are developing in parallel for the conventional materials. So, and this is in conjunction with 4 other institutions and very closely working with the Public Works Department, something like the DOTs or road traffic authorities. And one last module that I'm sure you might be interested to hear, and I think we've advertised this. Dr. George Souza, Dr. Camille Kaloush, and all of us have been talking about this, and we talked to Resources Conservation Recycling Journal with an impact of 11. So we proposed to have selected papers from this conference as part of special issue with RCR, and we were granted the permission. So there'll be 2 journals. One is the RCR main journal with an impact of 11, and RCR Advances, which is a sister journal but with an open access. So it's a paid journal, but it's an open access. You can go to both of these websites. Please visit. And the important dates are as follows. Full paper submission after we have selected top papers. There'll be a committee as part of this conference committee. Full paper submission will be December 2025, in the next 2 months. And then final decision after peer review. So it's it's not guaranteed that you submit a paper and gets accepted. So it goes through the process as per the journal recommendations, guidelines. Okay, it's a full-fledged journal, so we have to undergo this process. And publication will be immediate, online publication as soon as possible. So we'll share more details, and you see all the topics that are covered here: quantification of energy, CO2 savings due to rubberized asphalt or asphalt rubber with other products, but rubber has to be the base here. And then case studies. If you have case studies over the years, please submit your papers here. Life cycle assessment. That is actually the flagship theme of these two journals is LCA. So carbon footprint calculations and other things, please feel free to reach out to us. We'll share more details. Economic implications is the other, and material flow analysis. And so that's where we are with everything. And I have to thank several people across the world, including from the US, Sweden, where we worked on asphalt rubber. And we have also placed some test sections in Oman, in the Middle East, and it has been there for 10 months with no cracks. So we designed those from India, and I'll be going to Oman in the next couple of weeks to see what's happening there. But here's my WhatsApp and mobile number and my email. Several ministries in India, and several students, several universities, and several colleagues, excellent colleagues and students. Thank you very much.
Thank you, Dr. Krishna. Very interesting, lots of information to digest, and especially thank you for that special issues work that you have done there too. Questions, we are not too bad actually. We started about 20-25 minutes in this session, and we are just right on time. We can take a couple questions before the break here.
Chocolate is mine.
Sorry.
Chocolate is mine after your question. Go ahead, please.
Hello? Sorry, I know it's going to be difficult, but it must be at your level. Fantastic presentation.
Thank you.
But the reality is that there was someone from US that was from NCAT in return from US to India, and someone tried to do asphalt rubber, and he was absolutely politically powerful against it for reasons that...
Correct.
Right?
I know it.
So, India is like the biggest population in the world, second to China, and in reality has not been a lot of penetration in real roads.
Correct.
Other than the work you do.
No, we have got this big project after 10 years of research, so it took us time,
Right,
and I was... Yep.
If it wasn't for you, we would be in prehistoric times.
True. Okay.
My question to you is, given that we are going to do RAR 2028 in India,
Yes.
do you think it's possible that between now and then you can motivate more people to do more asphalt roads?
Yes.
And so that there's real
Yeah.
momentum. So
Yeah.
this is my challenge to you.
Sure.
Get us a few, but not 10 meters, okay?
No.
Can we do 10 kilometers?
No, we have got this big project where we will be placing across 26 states.
Okay, fine.
That's the project I mentioned, and this money is for the manpower. The construction funds are all with the government. So the government has released a directive right now,
Okay.
and I was part of this. I provided my testimony on including the evidences from ASTM, our studies from
right.
AR conferences. So we'll be placing at least 1,000 to maybe 10,000 kilometers in the next 10 years.
All right. Good job.
Thank you.
Here you go.
Dr. Hi. Congratulations, Krishna. It's a very good presentation. I have a question for you. Do you have cost the difference used to crown rubber or asphalt rubber with different MAR plus asphalt rubber?
Yes. Okay, let me go back one step and answer the other question as well. It's cheaper to use CRMB in India, 30%, like in many other countries. It's cheaper, CRMB is cheaper by 30%.
Because in countries like Mexico, Latin America, the recycling waste is not that cheap like here in Europe. I don't know in India, but
Yeah, so that is a circular where waste to wealth is very much encouraged. So CRMB is cheaper than virgin binders in India. So people have started to use it. Okay.
thank you.
Yeah, sure. And life cycle perspective, some of you are familiar, it's 50% cost effective. If you talk about life cycle, there's less maintenance for 10 years. And I told you there was a section that we placed about 500 meters. 2017, it lasted until 2020 when the state highway became a national highway. So not even one crack. And the contractors were very upset with me because they didn't have any work. And we also worked with Bitcoal to understand their product, and we've submitted the report as well. So it works very fine, as he mentioned.
Any other thoughts?
Okay. I'm
Question
available.
from my side.
Sure.
Are you doing any ME calibration for the mixes or the?
We are not doing any
yeah.
calibration. We are actually developing an ME guideline right now.
Okay.
We don't even have an ME guide in India. So that is another project that I have. I didn't mention that here. But this was asphalt rubber, so I didn't mention that. But we have a project with National Highways. We are developing our own MEPDG. So it started in 2020. So we have instrumented field test sections, and we are collecting data every day. And hopefully by next year, we should have the ME guideline.
Great. Good to hear. Any other questions, thoughts? Okay, one more big round of applause. Thank you very much. Next is a break. Have a good break. Please feel free to reach out to any of the speakers if you have any other questions. Thank you for attending this morning.
Congratulations. Adão, I'm from Brazil.
Okay.
We have, I saw the quantify of roads with asphalt rubber. 3,000?
No, 300,000.
300,000.
Yes.
Lane.
That's over the last 25 years. Main plant.
Yes. Yeah, we have 25,000.
25,000. Okay. This is a big country. We have developed a lot of
A
infrastructure.
lot of rubber in India.
More than 5 million tons of rubber has been used so far.
Just with bamboo rubber.
Yes.
And you see more, do
More
you have
more
more with SBS or more
There is
rubber
also
than
polymer. There's also polymer, but very, very few. Maybe 10,000 tons. 5,000. Less than that. Yeah.
main roads.
Yeah.
I work for Greg Asphalt.
Okay. You know Luis Di Mello? DNET director?
Yes,
He was
of
my
course.
classmate. He actually,
Yes.
I was going to say, he was also Professor Kalusha's student.
Yes.
Yeah.
Luis Alberto.
You're director of national. Okay, great. Let's keep in touch and we'll do something.
I take care of the factories of the
Factories,
company.
okay.
We have 8 factories spread in all Brazil.
Across Brazil.
Yeah.
Okay.
Congratulations.
Nice meeting you.
Nice to meet you.
Hi, George. Are you listening to me?
Yeah, are you talking to me?
Okay.
No.
Just testing if everything is okay. Now we are on coffee break.
Okay.
So maybe 10 minutes and we start, okay?
Is going to share the presentation?
Are you going to share something or you need us to share? Are you going to share your presentation or you need us to share?
Sorry, you are talking to me, or who are talking?
I was talking to you, George.
Ah, perfect. Thank you.
So I was asking if we now. Good morning.
Hi, how are you?
Hi. So in 10 minutes we are starting.
Okay, perfect.
Do you want to test if your presentation goes well?
Yeah, I want to test. You have my presentation, I think, and I have it too. What do you prefer, that I share the presentation, or
I
you
think
can...
it's better if you share. If you have a good connection, it's better if you share. Then you control everything.
Okay, can you see? Let me share you if you want to see if everything is okay.
Okay.
Let me share just 1 second.
Cameraman.
We have an infiltration.
I'm the mic man, I'm MC, I'm everything.
Só que eu posso fechar isto aqui.
Careful.
Can you see my,
Yes,
my
I'm
presentation right now?
I'm seeing your presentation.
I think
It was showing fine. So if you want to try again.
yeah. Let me try it again.
So when you share, you have the option to share the window. And then where you find the window, there's the presentation. You can put in full screen or not. It's up to you.
Okay.
But you have to open first your presentation. First, we have to open your presentation and then make share screen, okay?
So I don't know why I can't see right now my presentation here.
Yeah. So you are sharing your screen. Yeah.
Yeah, this is.
Yeah. Can
Let
you
me-
open now? Can you open the?
You can share only the presentation.
Yeah, I'm
You
trying
have
to do
already
that.
your
but-
presentation open.
Yeah, I have opened it, but I
And
can't.
you- when you
I can
do-
see in the window.
When you do share screen,
Yeah.
yeah, you have three options: Chrome tab or however window, the entire screen. If you select window, can you see window? The option.
Yeah. I can see the window.
You can
option.
select your presentation.
That's the problem, that I can see in the window my the PowerPoint presentation. That I don't know why. Let me open it again.
But you have the PowerPoint presentation running? You must be running the PowerPoint presentation so it will show on the window.
You have your presentation open,
Yeah.
yes?
Yeah, I have it open, but now in the presentation mode. Let me try it again. Wait a second. Let me see. Okay, I can see right now.
Yes. Yeah. Now we can see. Can you put this presentation in full screen or not?
Let me.
In the lower tab here.
Okay.
in the right corner.
Yeah, I'm trying to do something.
Or before you do this, share this screen, you can perhaps put in full screen modes, and then with the Alt tab, you can go back.
How do you see my presentation right now?
It's like
We see
when you are working on it.
Yes.
You know?
I don't know why, because I'm looking.
Do you have more than one screen? Are you working on more than one screen?
No,
Oh, okay.
just one. Just one screen.
Yeah. You are right. There. Yeah. Your mouse a little bit to the right. Down. Yeah, okay.
Yes,
Try
that's
to click there.
But I put here, and
Yes.
that's what I'm trying to tell you. I did it.
So
And
you
can-
have to, perhaps
So-
you chose the wrong.
Stop share screen and do this without sharing the screen. And after you have put it in full screen, you can go Alt Tab and come back again to the meeting, and then make the share screen.
Okay, let me
So
try
close,
to do that.
stop sharing now. Stop sharing your
Yeah.
presentation.
Okay,
Okay. Now go to your presentation and
Yeah.
put it in full screen.
perfect.
Okay. Now go to the Meet and make share screen again.
How can I do that? That's
So you can go like Alt Tab. If you push the Alt and Tab, it's the key on top of caps lock. You know, that key that you go to make a space, a big space.
okay.
You can see what is open. They will show you what is open.
Let me try again. For example, like that.
Yes.
Okay, perfect.
Perfect.
Now it's
Perfect.
working.
Don't touch. Okay. We.
But let me.
It's perfect,
and,
yeah.
and how can we change? How
So
can
now
I change?
you have to go to your presentation. Again, Alt Tab, and
Posso fazer uma pergunta?
Okay.
and then you can change it.
Okay.
If you minimize your meet, yeah, it's changing already. Okay, it's perfect now.
Okay.
Okay, it's working. It's perfect. We see you, and we see also the presentation.
Perfect.
Okay,
Okay. We can wait for
the end of
Coffee break.
coffee break. So I will put this here. Okay, so it's perfect now.
Okay.
We're gonna take a break 5 minutes, okay?
Perfect. No problem.
We'll be outside 5 minutes and we'll come back. I'll try to run everyone.
Olha, o microfone está aqui deste lado, pá.
Okay.
I'll try to push everyone to the room in a minute, okay?
No problem. I wait for you. No problem.
Okay.
Thank you very much.
Tá bem. Olha, vou beber café. Já bebes café?
Olha ali a parede. O que é que tem lá colado?
Aí é bem.
Com estas luzes.
Com estas luzes é que se vê bem. Aí é com caraça. Olha, chama a Rita.
შეეხება სატურუსსაც და მემერცაც ძალიან საპატიო კომპანიებია და შესაბამისად ჩვენ სიმხიოთ არა ვიქცეთ წინააღმდეგი არა ვარ თუ კომპანიები ვექნება ჩვენი და ხო მაგრამ ისეთი ის კარგი თავიცი აი თქვენ დაეკონტაქტეთ მაშინ შესყიდოთ Solomon აუგზავნოთ მაშინ თქვენ ესე რა ქვია თქვენი მონაცემები იმეილი რაზეც უნდა გამოგეგზავნოთ ბაზრის კვლევა ახალი ბაზრის კვლევა ბევრი რაღაცაა და კიდე გამოცხადდება უთხარით რომ გაინტერესებს ყველა არამარტო უმერები არამედ ყველა რაც გამოიგზავნება ბაზრის კვლევაზე ისინი თქვენს გამოგიგზავნოთ და ერთ-ერთ როგორც პრეტენდენტმა მიიღეთ ამ ბაზრის კვლევაში მონაწილეობა და სოლომონს, იმიტომ რომ მე ხარ ვერ იმასვი, მე როგორი რაღაცა იცით საერთოდ ბაზრის კვლევის თვითონაც ახალი მისული ვარ დეპარტამენტში ბაზრის კვლევის პერიოდში პრეტენდენტებთან კომუნიკაცია ჩვენ არ ვიყურებთ მაგრამ ჯობია ეს მაინც გაკეთდეს კომუნიკაცია გაკეთდეს შესყიდვების გამო ანუ სოლომონი არის საერთაშორისო შესყიდვების გაყოფილებაში მუშაობს არიქენზე ლოკალური შესყიდვების გამო სოლომონს გადაუვია მე-13 დიდი ალბათობით კი ბატონო და ტექნიკურ რაღაცებზე ჩვენ შეგვიძლია გავიაროთ რაც შეიძლება აი ეს იურიდიული ხაზი და აი თვითონ ის გამოეგზავნოს ის გაეგზავნოს რაღაცა ისინი მანდონი ამგენ ამ სიას ანუ შესყიდვების სამსახური აგზავნის შემდეგ ჩვენ მიერ შედგენილ ტექნიკურ მახასიათებლებს პოტენციურ პრეტენდენტებთან და ჩვენ სოლომონს გადაეცით თქვენი საკონტაქტო ინფორმაცია თქვენი ორგანიზაციის მიხედვით როგორც მეგობრებო სადაც გინდათ რომ მოგიიღოთ ეს ინფორმაცია და უთხრით რომ არა მარტო ღუნულებით არამედ ყველა გამოცხადებული ამ ლაბორატორიის შექმნისთვის ყველა გამოცხადებული ასისტირების პროცედურებში გააინტერესებს რომ მიიღოთ გამოგიგზავნება ტექსტილები მერე უკვე არა თქვენ კი არა თქვენ თუ წარმომადგენელი ხართ კომპანიების თქვენ ესეთი თქვენი წინადადება უნდა დადოთ რა რაც
Hola Jorge, George Alarcón, ¿cómo estás? ¿Dónde está la cámara? Cámara está aquí.
¿Qué tal, Jorge? Todo muy bien, ya te veo, ahí te veo. Ahí te veo aparecer un poco ya. ¿Cómo estás?
I'm really sorry you couldn't make it here, okay?
No problem.
Next time. Impressive
I hope to see
presentation,
you.
eh? It's really impressive. Thank you.
No, thank you very much for the invitation and for everything, for all your attentions. And I'm here waiting for the start of the presentation. And thank you, Jorge.
მაგაში ჩვენ ხო არა რა თქმა უნდა უბრალოდ მაგას ჩვენ არავითარ შემთხვევაში ინსტრუქციას არ მოგვიყვება ჩვენ უბრალოდ ხო პასუხი უპასუხონ არ დაიგნორონ და ხო რა თქმა უნდა კი კი არა არის ხოლმე არის შემთხვევები რომ არ კონტაქტობიან არ პასუხობენ და რაღაცა და ხო ამიტომ რაცემ პასუხი როგორც არის განლაგებული განზე გადმოხმის სამართლება თუ ის ჩვენთვის ამას აბსოლუტურად არავითარი მნიშვნელობა არ აქვს ჩვენთვის რა თქმა ინტერესებს ამოჩენ უბრალოდ ყველას პასუხი გააცნო რა ვიცი მე წლების განმავლობაში კონტაქტის მქონე მაგალითად ამ სფეროში რა მესურვ ტექნიკური მე სამუშაოდან გამომდინარე კარგი თოში კარგი ჩემთვისაც და ხოთ მიიღოთ აქტიურად მონაწილეობა კიდე იმას გეტყვით რომ ფასტაკვლევის ეტაპაზე ნებისმიერი კითხვის დასმის უფლება გაქვთ ანუ რაღაცა მაგალითად თქვენ მონაცემები შეგიძლიათ თქვათ რომ დასვათ კითხვა რომ აი ეს მონაცემი მაგალითად თუ შეგიძლიათ ამიტომ უყურეთ ეგრო ასაგები ხოდა უყურეთ მე რას ვუყურებ შეცდომისაგან არავინ არ არის დაზღვეული ამიტომ ფასტაკურეთ ფასტაკურე რას ვუყურებ ფასტაკურების არც მე არ ვარ დაშორი არის სხვა არც არა ამიტომ მე რას ვუყურებ ფასტაკურების ეტაპზე თხოვთ იაქტიუროთ თუ რაღაცას ნახავთ ან რაღაცა არის იბერძოებულისგან სასურველი ან რაღაცა ოღონდ ჩვენ რაც შეეხება ხარისხის მოჩვენებით ეს მომენტს არაერთი ანუ ხარისხის მოჩვენებით ეს ჩვენ ვერ დავთმობ რაც შეეხება დანარჩენს არის ხო ტენდერი იქნება მეორე ეტაპზე რა ტენდერი იქნება მეორე ეტაპზე ასის კვლევაზე ეკეთებს ანუ სრული უფლება რომ ტექნიკური ნაწილით შეაფასოს და კომენტაროს ასევე თქვენ შეგეძლიათ კომენტარებში მოხდეთ მაგალითად ტექნიკურ დავალებას ქვემოთ მოუწევს მე იურიდიული ნაწილი სახელმშეკრულებო ნაწილი რა ანუ იქაც შეგვიძლია თქვენ გადახდის პირობებზე, საგარეო პირობებზე, კიდე ალვასის გაცემაზე, მაგალითად გრაფა დატოვებული სპეციალურად, მაგალითად შეიძლება დატოვებული იყოს სიტყვაზე 50% ავანსი, რაღაცა 30% რაღაცა 100%. ანუ თქვენ რაც სრულ აი ამ ეტაპზე შეგიძლიათ გამოცხადებული სტატუსში გამოცხადებული ინფორმაცია სრულად როგორც ტექნიკურ დაცემაზე, ასევე იურიდიულ ნაწილზე. ხო, გასაგებ, ხო. აი, გემაშინია. ჩი ჩაქსულეთ და თქვენ ესაზღვროთ არა, ყველა ვარიანტში დაგეკონტაქტებიან და უთხარით, რომ ნიკოლოზი არის ლუკაკუს შესაძლებელი. ნიკოლოზი ნიკა არის ადგილობრივი შესაძლებელი და გვარი გეტყვით.
Eu fui passear numa volta lá no Chiado e num restaurante muito bom de noite. Foi estava bem gostoso. Matou um povo ეს აზრი არ აქვს, იმიტომ რომ ისინი იმას მოგწერენ, რაც
That's okay, it takes. Claro.
Nós temos
Está bem, ok.
isto, as pessoas deixam aqui, partem, e houve uma senhora que já cortou a mão a sério, a ir buscar a mão porque ninguém disse nada, ficaram lá os vidros. Pronto, é só por causa disso.
Jorge, você falou que estão usando muito Alex lá no ambiente, né? Tem uma empresa que está, que a gente assessora lá na República Dominicana,
Sim.
que eles estavam querendo modificar o asfalto.
Ok. Isto é melhor. Na obra.
Da outra vez que a gente trabalhou com eles, através da Odebrecht, fizeram patrocinado da Odebrecht e a gente usou o Valor, misturou lá na obra. Mas agora não tem mais o Valor, tem empresa.
Ok?
Depois,
Fala comigo que eu
mais detalhe para a gente ver. Na realidade, eles querem um projeto grande lá na República. Pavimentar Santo Domingo a Santiago. Trabalhando.
E é na camada de desgaste ou é no...
Não, a camada de desgaste.
Pronto, isto é o ideal. É ideal. E eu digo, como é que está muito partido? Como é que está?
Não, o pavimento está. Como ele é muito.
Diga uma coisa, você depois da manhã vai ao tour?
Não, não vou. Mas a gente conversa.
É para você sentir, quando eu começar a falar, conversa, se eu agora disser, ok, assim de repente eu vejo duas alternativas, 4,5, 5, a mistura gata, como é na Califórnia,
Sim.
e tem que pôr bem 8% de ligante, 8%, sim, por aí, para ser mesmo bom, não é para brincar, é para ser bom.
Mas ele mistura nessa, vocês usam também?
Não.
Deve ou
A granumetria, deixa eu responder. A granumetria é como a open, mas não é open. Tem 3%, 4% de vazio. Tudo o resto está cheio. Mas aí, esta outra, tem penso duas maneiras. 4,5 ou 5 da guerra. Que vocês conhecem. Ou 2,5 de uma open de granumetria, mas tem 12% de ligante. 12.
aí acaba saindo muito caro.
Por metro quadrado sai menos.
O asfalto lá é muito caro.
Sai menos. Não é 12, é só 7 de lima. O resto é borracha não sai caro.
Mas o 7 é um teor alto, né?
Tá bem, mas é só. Se você não fizer isso, o que você vai fazer?
Não,
Vai fresar?
Não, é porque ele quer contornar um modo que um distribuidor lá está exigindo um modificado com polímero que é menos 76, menos 22.
É isso, dá logo assim. Isso aí fica muito melhor. Sim, sou eu.
É você o moderador e isto é online. Está a brincar? É online, é o primeiro. Não, estava aqui, nunca mais começava.
I'm so sorry, I forgot I was the moderator. So we are ready to start with what I think is a fantastic presentation from Professor George Alarcon. And George, when you are ready to go, we are ready to receive you.
I'm ready. If you can hear me well, I'm
Very
ready.
well, yes.
I can start right now, or?
Yeah, you can start.
Okay, perfect. Thank you very much. I'm really glad to stay here today to share with you very nice research that we are making with the University of California and Davis. And I want to show you what we are doing the last 2 years about this interesting research. So I want to thank all the organization of this interesting conference, especially Jorge Sousa, for all your attentions, and thank you very much for all the organization, and I'm very happy to stay here today. So I want to thanks to all the team that work in this research, and especially I want to thank Ángel Mateos, who leads this research at the University of California in Berkeley, and to thank to John Harvey, to work very hard in this project in the University of California at Davis, and all the partners that make that possible, and it's very, very interesting work. So I want to talk to you about the motivation of this research. In California, they have a lot of cars and trucks, and if we can see the results of the report of Car Recycle, they have like 57 millions of tire equivalent units of tires every year. So they don't know how what to do with that quantity of tires in California. So they are working for the last 20 years in different ways to make something with that tires in the end of life. So they are working with Caltrans, the California Transportation Office, to do something to use the chrome rubber in the pavements in California. So they have been working for a long time with the rubber hot mix asphalt gap graded for the surface layers. So they can use right now about the 13% of all the end-of-life tires in California. So they used to work with that kind of asphalt mix named rubber hot mix asphalt gap graded. Why they use that kind of asphalt mix? Because they can use a lot of rubberized asphalt in that kind of mixes. So they use this kind of asphalt mix in the surface layer, and they know very good how to do that kind of hot mix asphalt. If we can see in this slide, we can see the benefits of use that kind of mixes instead of the hot mix asphalt typical that they normally use. Why? Because they have a higher ductility in that kind of mixes, and they have a very big life with that mixes. If we can see the results of the ideal cracking test, that test is very common in USA to can know how can you make more ductile your hot mix asphalts, and it's very clear to see how can you improve fatigue life in your mixes. So you can see in this graphic that the mixes with rubber asphalt, the rubber hot mix asphalt gap graded that they use, have a very big CT index, and you can see that it's very good for the reflection of cracking. So that's why they normally use that kind of hot mix asphalt. If you make, for example, a 4-point bending fatigue test, you can see that you have a very big increase of the low repetitions that you can resist with that kind of mixes. So they are very happy working with that kind of mixes. So why do we need more research about rubberized asphalt? Because they want to make another kind of hot mix asphalt with rubber asphalt too. And they want to see if they can use more rubber asphalt in another layers, not just in surface layers. So Cal Recycling and Caltrans called to University of California at Berkeley and Davis to make a very nice research about using hot mix asphalt with RAP, reclaimed asphalt pavements, and rubber asphalt. So that's the motivation of this research. They want to explore different kind of mixes, and they start to make a very nice work with the rubber hot mix asphalt dense graded to increase the use of rubber asphalt in the roads in California. So they ask a lot of different technologies to make part of this research. They want to show how can we improve the behavior of the hot mix asphalt with RAP when we use the chrome rubber. So they start with a lot of different technologies, the normal technologies of wet process, but they want to use a different technologies like terminal blend and the engineered chrome rubber mixes. We have a very nice product named RARX that it's an engineered chrome rubber modifier that you can put it directly to the mixer of the plant. And they invite us to work in that research project. That research project have 3 phases. The first one was a lab phase that it's concluded 2 years ago, and we identify existing technologies for introducing rubber into dense graded mixtures. We start with 30 different technologies, and we want to identify the potential construction problems based on the lab workability and mixed volumetric analysis. The phase 2 was a lab evaluation too, and we want to look for the effect of tire powder on the mechanical properties of the mix. This is concluded too, and they select 4 technologies, just 4 technologies: 2 terminal blend, 1 wet process, and the RARX. Why these 4 technologies? Because they find the best results with that 4 technologies. The phase 3 was a field pilot test completed 3 months ago, and it's a very interesting work that we do with them to see the field behavior of that kind of mixes in California. The road test was in Leaf Road, Garrod Drive, and this is a pilot that made with the University of California, Davis, and we did a rehabilitation of 2.6 kilometers of a 2-lane road with the different technologies that I told you. The partners of this work was US Polico, right, with 2 terminal blends, chrome rubber manufacturers with the add wet process, and Neotech Asphalt with the RARX. That was the 4 technologies that we study in this pilot, and I'm gonna show you the results of the different phases of the research. In the first and the second phase, we test in lab different kinds of properties properties of the mix, and I'm going to show you this one. This is the result of the cracking tolerance index, CT index, and it's very interesting, but because this is very clear to see how can we improve the fatigue resistance in the mixes. You can see the control mix, that it's a normal mix that they use with RAP and a normal asphalt. And we have the 4 technologies with rubber asphalt that we try in this research. The first 2, TB1 and TB2, was the terminal blend technologies. Then you have the add wet technology, and we have the engineered chrome rubber modifier, RARX results. If you see the results, you can see that with the add wet and the RARX, we can improve like 3 times the fatigue resistance of these mixtures. This is very, very, very interesting. And if you can see in this graphic, we can see the resistance to deformation in Hamburg test. This is very, very, very interesting results because we can improve a lot of fatigue resistance, but we don't have a deformation in Hamburg test. That means that we can make a very, very, very ductile mix with the chrome rubber. This is, remember, this is lab results. What else we can see with this research? We have a very small increase in the cost of the mixture. If you compare with the control mix, we have, for example, with the RARX, 18% of increase of the cost. And this is the cost just for the mix. It doesn't include the transport and paving. So we have only 18% of increasing cost if we compare with the control test, with the control mix, but we increase like 4 or 5 times the fatigue life. So I think that it's very interesting. And if we can see the emissions that we have with that kind of technologies, you can see that if we compare with the normal rubber hot mix asphalt gap grade that they use, we have less than the half of the emissions that we have with the normal technology that they use with the rubber hot mix asphalt gap grade. So that's very nice too, because we have less emissions than the normal mixture that they are using right now. But in the pilot, we want to see if we can make in the plant process the same benefit that we have in the lab mixes. So that's why we make the pilot in the land, and we compare the different technologies that we use: terminal blend, add wet, and the RARX with the control mix. What is the feedback of the team of compactation crew? They said much easier to work than the rubber hot mix asphalt gap graded. It's easier to compact exactly like a hot mix asphalt normal, less gas odor, and they said that the good compactability of the rubber hot mix asphalt dense, it's like a hot mix asphalt. And we have a support of these results by the coarse density that we obtain of the road. And if we compare the results in the plant mixes with the lab mixes, we can see that, for example, with the RAR-X, we have better results with the plant mixes in the cracking tolerance index than in the lab mixes. This is very good because we can reproduce the same results in the plant mixes than in the lab mixes. So this is very, 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 very interesting. And what are the conclusions of this work? The rubber hot mix asphalt dents can be designed for surface and below the surface layer application. So we can use like a surface or below the surface layer application. The cost of the rubber hot mix asphalt dents, its environmental impacts, and it's comparable to a standard hot mix asphalt and much better than the rubber hot mix asphalt gap graded that they are used right now. And based on the initial laboratory test, the cracking resistance of these mixes is considerably improved compared to the hot mix asphalt. We need to wait for the long-term monitoring of the Leaf Road Garrow Drive test, and we are waiting for that results. And thank you very much for your time, for this space, and I'm here for any question or for any comment of this research. Thank you.
Thank you, George, for your great presentation. We have time for one question. Okay, I have the question. You have not done a flexural fatigue test, not yet? You will do?
Not yet. Not yet.
I think it's important.
We are waiting for the 4 points test in lab. So we are going to have that results in the next month. In November, we are going to have the complete test results, and we are waiting for the 4 points bending beam results. But we think that we are going to have a very, very nice results.
Okay, thank you. So, thank you, George. Great presentation.
No, thank you. Thank you.
Our next presenter is Antunes from Italy, and she has also a very interesting presentation. Can we change the screen? Hello? Ah, there you go.
Okay. Hello to everybody.
No, go.
Better now? Okay. Good morning to everyone. I'm Ines Antunes, the R&D director in Polyglass. Polyglass is an Italian company from Mapei Group, very, I think, known Italian company for building and construction products. And today I'm here to share with you a work that we developed in cooperation with the University of Calabria. You will also meet Professor Rossi, under a PhD, the PhD of Concetta Bartuca, that also spent some time here in Portugal with Consulpav, that we think from the beginning. Today, till in the last 2 days, we have spoke a lot about, let's say, the main use of crumb rubber, which is in roads. In Polyglass, we produce waterproofing membranes for roofings, which maybe you don't know what is a waterproofing bituminous membrane. It's a black roll that is used to waterproof the roofs, also to waterproof tunnels, bridges, and you might think it's a niche market, compared to roads, maybe it is, but only in Italy is 100 million square meters market yearly. So it's a very huge market. What is a waterproofing bituminous membrane? So we take a carrier and we impregnate that with bitumen, and we put bituminous compound on the top and on the bottom. Bituminous, and I feel a little bit constricted here, but usually they are torched or they are self-adhesive. So they are applied with flame on the top of the roofs. So you must keep in your mind this type of application. We have a ready-to-use black bituminous roll that we will torch and apply and needs to be on the roof. So it's actually very challenge to formulate it because we use sorry about this, okay, because we need, it changes, but I'm not doing anything. You see that? Okay. Anyhow, so because we take a bitumen, and you need to put, I will not argue with this, and you need to put some polymer to change that compound. Usually the polymers that are used to modify roads are elastomeric SBS. To produce the waterproofing membranes, we also need to put some polypropylene, which might be, let's say, it's a plastic, and we put that to increase the stiffness. Here we are looking into what say it's the standard, the classical characterization of bituminous membranes, which is actually similar to the one that you use to roads. Why do I need you to focus on that? Because you see that the standard characterization is taking a single picture of the behavior of this compound, and we have cold flexibility. Like, for instance, for roads, we have the FRAS, because you need to think of this product that, yes, it is on the top, and usually we don't apply into negative temperatures, but it is also storage in warehouses, and you need to apply it under severe. But why did I did this movement? Because it's a roll, and you really kick it, and you need to apply it and under negative temperatures because it's worldwide used. Then we have the penetration, like it's used for roads, which actually is giving me the idea of how soft it is under, let's say, environmental temperature, because it's on the top of the roof and you are supposed to walk on it. Then we have softening point, which is an indicator of how much modifier you are putting into that. And viscosity, that is measured at 180 Celsius degrees, is for production. So we have this picture on the range temper that follows the behavior of this roll during, let's say, its life from the production till the application. But we don't have the old picture, and that's why we decided to go deeper. Now, when I show you those temperatures, you already are thinking, why there is such a limited examples of using and putting rubber into waterproofing bituminous membranes? Because you know how performant it is to use this material into roads, and things are not changing a lot, even if we are in roofs. But still, we have even more complicated thing, which is the UV resistance. The sun is very aggressive, and we have UV resistance. What are we doing to improve the performance, to avoid that bitumen that needs to stay on the top of the roofs for hopefully more than, because you know when you build houses you don't want water to get into your house, so the membrane cannot crack. We are putting some oils in order that we have flexibility and that we have UV resistance and some very, let's say, polymers. So here we decided to understand from the chemical point of view the behavior of different bitumens, a very high, let's say, penetration bitumen and a common road bitumen. We put some RAR on that, and so we took the RAR that you know, the product that was developed by Sozas, and we also added this oil. In this study, because can you think about a more sustainable material than putting recycled chrome rubber together with maybe a waste oil or a bio oil? You can't. So we decided to put some sustainable and to give some sustainable to, let's say, label to this black roll made of bitumen and to study it deeply. So what we did under this investigation, the first thing that we have seen is that when you do some mixes putting polymers and bitumen and no oil, you get a phase inversion, you get a compatibility that is not so good. When you add oils into that, compatibility will improve. And this is very important because what we have found out, the first thing that we found was that bio oils actually act as a stabilizer, and it will improve my system, other than, as I said again, being a very sustainable product. So we decided to step forward because also, you know that Concheta, she's a chemist, and when she sees things, she wants to understand deeply what is happening behind. So we decided to start from the chemistry of bitumen and from the chemistry of the rubber and from the chemistry of the oil to better understand. And we did some separation. So we took these two types of bitumen, 160 and 5070, and we went to separate that using techniques, advanced techniques of separation with solvents. So we took the asphalts, we did the precipitation, and what you can see when you extract that from the bitumen is that residue, which is very important because, as you know, asphaltenes will give me the stiff. The maltenic part is where usually we get the reaction. But and this is what was, let's say, was real innovation. Maltenes are also, let's say, the main responsible of oxidation. So you really need to control it, and you really need to improve this part of the bitumen. Then we have the maltene separation here using this system of chromatographic column, and we went to do this NMR, which is very sophisticated technique that Professor Oliviero Rossi uses in Calabria. And what you see here is that we started from, you look into it, and those are two similar bitumen, but they are very, very different, because when you look to the aromatics, which is the responsible of the compatibility between bitumen and the polymer, bitumen and the rubber, the performance and the behavior that we have on the top of the roofer, which is strongly, let's say, interacted, connected to the life and to the shell life of the roof, we see that here we have very, very different. And this is probably something that you are not used to see. Usually you don't see NMRs of bitumens, but what we see is very, very well identified the part of aromatic and the part of, let's say, saturates on the right, and also asphaltenes. So we, at this point, put the rubber into to this, but we decided to change things, to mix things a little bit, and in Consulpav they like this very much. In spite of saturating the RAR with bitumen, which you know that is usually how they do that, we decided to saturate the rubber with oil. So what we did was to produce the rubber, increasing the temperature. The rubber will absorb this oil that we are putting. In this case, we put the bio oil and a waste oil from McDonald's, the one that they used to fry the chips, and we put that into rubber. Why are we doing that? Because when you put rubber into bitumen, actually what rubber is doing is to absorb the maltenic part of the bitumen, which can be good, but which can also, let's say, be a problem, because in our case we need to have this very UV resistance, and we also don't like very much during production to have high viscosity. Viscosity in our case is an enemy of the production capacity, because lines need to go fast. So this is something different. We put the rubber together with the oil, and then we did mixes. We went to chemically change, because here we have a chemical interaction, not only a phase inversion, physical inversion, but also chemical interaction, by putting 5% of RAR. So 5%, it's, how can I say, a percentage of the modification that usually used to produce modified bitumen SBS hard. But what you don't know is that for membranes, this is a very, very, very low amount of modification, because since these rolls need to be solid at environment temperature and you need to stock it on warehouse, usually the percentage of modification that we use are much, much higher with SBS. We put 10% of SBS. We put, when we use polypropylene atatic, sometimes we put 20%. But only with 5%, in this case, we had a very, very good result. So here, we did some rheologic analysis. Here, what we are looking is to, let's say, the standard behavior of a viscoelastic bitumen. And as we expected, in spite of having very, very different chemical composition, what we see here is that a 50-70 bitumen is stiffer than a 100 and 200 bitumen. Let's see what happens to these two very different bitumen when we put this 5% of modified RAR with oil. As you can see here, the first thing that we assist is that usually, and here it's very small, but you can find it in the paper, we did the modification, and then we also did some RT-FOT and some PVA in order that we simulate this oxidation, also this UV resistance. And what you see is that only by adding this 5%, we don't see anymore the influence of the neat bitumen. So these different behaviors that we had between the two bitumens, as you can see, the behavior of the rubber will subscribe the behavior of the bitumen, these differences, and we slightly improved the resistance to aging. So the system is very stable. The system, even after aging, the system stays very elastic, because here, of course, we are doing recovery. So we are measuring the elastic and the temperature sensitive. And the same thing happens when we move. Sorry, of course, here we are at the range of high temperatures, so between 50 till 100 Celsius degrees. Same behavior we can find when we look into the bending beam results. So we are looking into behavior of the mix under 0 Celsius degrees. In this case, we will join also negative temperatures, minus 24 Celsius degrees. And again, you can see that the combination between rubber and oil will give the system more cold flexibility, more resistance to cracking, and also the system is stiffer, which is very good to the fact that you need to have a solid roll that you can stock and use it later and also flame it. So the results were very, very enthusiastic. But we were not happy, and we decided to call the Rossi, that the professor was not happy because they are chemists. Let me share this with you. So at this point I was very happy, and I said, we found it, this is revolutionary. But he said, no, because how is it possible that the rubber is absorbing the oil and then the oil is not coming out anymore? And he decided to study it deeper. Thank you.
Yes, thank you very much. Okay. Just a few words, because the presentation is quite clear. Thank you. And thank you because you invited me in this Congress. I am a chemistry. I belong to the chemistry department of the University of Calabria, and we use usually several physical chemistry techniques to understand the bitumen, the structure of the bitumen, and how the structure change when some additive we put inside. For us it's important, this point of view, because it's a strong connection between the engineering world and the chemistry, because if we know the mechanism that governs some modification in the bitumen or in general in the material, we can design much better future additive for the market, for the real market. Okay. So my topic is, in general, is use the physical chemistry technique to to study the structure of the bitumen and the material. In this case, we use the NMR. NMR, I think, is a common noun, because now in the medicine, everybody know I have a problem, I go to the hospital, I make the magnetic resonance imaging in that case. The principle is the same. There are different kind of technique of NMR. In the previous slide, we show the particular spectrum of the bitumen. In that case, you can understand the polar region, the aromatic region, the aliphatic region, which kind of atom are present in the system. Usually, the chemists use the NMR to understand if some synthesized molecular are good or not. So we can understand how each atom is bonded to another atoms, for example. In this case, it's different. We use the self-diffusion NMR or relaxometry NMR to understand. I don't want to annoy you with the specific technique because it's very hard. Okay.
The problem is the time. We love it. So,
okay, so
otherwise,
okay, yes, sorry.
Just
we say this: we can understand that we can study the mobility of the molecules. By the mobility, we can understand the structure of the mobility occurs. Okay. In this case, we use the self-diffusion to understand the limit of the absorption of the crab rubber of the oil. When the mobility is very low, it means that it's absorbed. When it's increased, the mobility, we can say it's outside. It's like average of the low mobility and high mobility. The same thing. Okay, we use the relaxometry, okay, when you load the system with energy, the system relaxes the energy. According to the relaxation, we can understand the mobility, the rigidity of the system. From this information, we can understand where the oil is, when it's inside, when it's outside, so we can understand what happened. For this reason, the oil in this case is inside the
crab rubber, okay, and of course is limited to absorb the light part of the maltine. Usually in our previous investigation we know this. You put the crab rubber, they absorb the light part of the maltine, the rigidity increase. In this case we avoid this. Another important thing is this. The fatty acid are very important to stabilize the crab rubber. When you put the crab rubber in the bitumen, in general, okay, like surfactant, let me say, you have a strong separation, is a big problem. So the fatty acid generally stabilize the system and avoid sedimentation or limit the sedimentation. Okay.
Jumping to the conclusion.
Thank you.
We just want to thank also Consul Pav, and it's very good always to discover new things that are important to industry, making a friendship and having fun. Thank you. And thank you, Concheta. Concheta is very shy, but she did the whole work, and she's amazing. Bye.
Thank you so much. We don't have time for questions. You know, fabulous presentation. Thank you. So now we have Jeff Rowe presenting the performance of devulcanized rubber asphalt modifier for the production of polymer modified asphalt rubber, after binders.
Okay. Have to see where it is. Go there. Okay, we found it. So,
Fernanda, how do you do this? This is yours?
Yes.
So just go there, see, strike.
Here we go.
Yeah.
Very good. So I'm Jeff Rowe. I'm going to talk a little bit about this. We'll try to go reasonably quickly because I know lunch
10 minutes. I'm so sorry.
Just around the corner.
Yes.
Very good. Well, so what we want to talk about today is a presentation with a rubber which we're describing as devulcanized. Tony, who is with me here, will go through the company structure. The other folks I should mention, Marty, who's in the middle there, is an esteemed colleague in Washington, couldn't be here today. Victor's has been doing extensive work and he's contributed to this. And also I should really mention Joe DeBrola and Sergio, who's sitting in the back, who's also helped with the analysis. With that, I'm going to pass across to Tony for a few minutes.
Thank you. Hello. So this is our format here, pretty much breadcrumb style. Right now I'm going to talk about who Regen RBR is. Kind of going back to this, kind of in a nutshell, we're taking tires, we're reducing them to powder, and then we are running through a devulcanization process, sometimes with performance additives to meet certain specifications, and then we're making a pelletized devulcanized rubber that is an SBS replacement. So the structure is that we have two facilities in Lithuania. So we have a tire shredding facility, which is a sister company to Polylemma, our European subsidiary, and they both roll up to Regen RBR as the parent, headquartered in DC. I won't go through this. It goes through some of the details. We have a QR code on here, just some of the capabilities and standing, where we're at. We do focus on, I mentioned we have some different products. We have flagship products. We also have these high-performance products, which are effectively the same as engineered, where we have found the applications to engineer them in a way that they could be used for, maybe higher elasticity, elastic recovery, massacre in the U.S., stuff like that. But we do have the ability to work with customers and further engineer solutions for them based on what they need. We go into paving, we go into roofing, we have rubber compounds, thermoplastic elastomers. Again, you can read this later, just pretty basic, substituting more recycled content with savings. Also, mixing time is enhanced. A lot of stuff here. I won't touch on it. So this one I will touch on a little bit. So we have a life cycle assessment, and very quickly methodology is cradle to gate, everything from taking the tire, shredding it, removing the metal, and then transporting it to the devulc plant, and then packaging it ready to leave using standard tire formulations from U.S. Tire Manufacturer Association. And then, sorry, I don't have my glasses. Oh, and we're using the EcoInvent database, which is not required for LCA, but it's become the standard for EPDs. So we decided to use it for both, even though we actually get a worse score on the LCA, but we wanted to be consistent. And here we have a reference formula for how we did this. And what it's really showing is that our footprint is 0.37 kg or 370 tons CO2 equivalent. And we do get a credit for the steel, and so we have a footprint of 0.03. We're looking at some ways that we could actually go negative carbon by using solar panels and stuff like that instead of electricity. This is more on the EPD line, but I won't touch on it too much. It's not a realistic analysis because people wouldn't normally do this, but if we took the same raw ingredients and built it up like what we're making, and then we looked at the carbon footprint for each and we did a weighted calculation, we see that we have 79% carbon offset. We did this actually for a system SBS 3.5% SBS, and it was about 75, 76. So it's pretty close, and we can do this for applications and help people to get their the LCA in line as well as EPDs. And I think with that, I'll turn it back over to Jeff.
Yeah, thanks very much, Tony. So one of the things I want to just tell you is we do have a QR code on the last slide that you can download this presentation. So if you want a copy of it, either see me or get that QR code. So in terms of modification, we can look at modification to EN standards, and if you look at EN standards, we're talking about trying to modify, increasing the softening point while maintaining flexibility. The key takeaway from this slide is, if you look at the softening point ranges, we can either 10, 15, 20% addition levels get into different spec boxes, and some of that details in the paper there. Looking at the conventional rheology versus things you need to do with rubber, we've looked at the gap size effect, and what we see with this product is we're pretty much going into an asphalt system like a conventional polymer modified binder. We don't really see any big differences between 1 millimeter, 2 millimeter gap sizes. Other studies like the work we've done in South Africa, on other types of rubbers, you'll see you have to make some adjustment to gap sizes, but with this material, you don't need to do that. In terms of modification levels in the super paste system, depending on what percentage you use, we see that we can achieve the similar modifications to basically an SBS type binder. The red there is the SBS, the black is 2 control examples, and the green are the PG spreads that we are getting from these products. And they're very comparable systems, but we have a higher dosage level. We're generally looking at dosage levels in the 8 to 10% region, whereas, SBS, you might be down 3-4% region. I like to use this chart. It's a very useful chart for trying to understand modification level. It's a bit like your blowing curve on your pen softening point chart, but this is something that Olga Putzik with ESSO in Canada suggested a number of years back for trying to look at the quantification and the value added with a modification. So the amount of that vector as you go up from an unmodified product to a modified product, really if you start put dollars on that vector, you can start to assess the ability of a system to move a product from one specification to another specification. We spend a lot of time looking at master curves, and folks who know me know I've looked a lot at master curves, and if we look at the rheology, we want to define the shapes and the point parameters that are coming out of the master curve. The shape parameter really defines your relaxation ability, a bit like the M value in the bending beam rheometer. Your point parameter defines your hardness and the ability of the material to attract stresses. Once you've attracted those stresses, you've got to relax those. So, this is what it's all about and why we're interested in master curves. The master curves, if you look at a black space plot, here you see a typical example of a modified product with the regen modifier. So we go from, say, in this case, the 6416 original to a modified, and you see that plateau effect, that vertical line coming down with the blue data points there is the fact that you're generating this network type effect when you modify. And we've looked at this with different aging responses to try to qualify materials. Obviously, every binder you put this system into is going to give you a slightly different behavior. This is showing the example with a PG 6416 and how we look at aging studies with that. And we're comparing that, in this case, against the Glover row at 0.005 rads and 15 degrees C. And you can see how you might progress across a cracking parameter of some kind. In terms of the work that we're doing with parameters, we're basically cataloging a wide range of parameters to look at the different quality aspects that folks are looking at. And the way we see this going is, I can give you this presentation, and I'm not going to go into that table, but the way we see this going is with the shape and point parameters, what are we going to see the industry coming out with in the next couple of years? My guess is that the Glover row parameter, the test at 10 radians per second is going to be for the preferred point parameter, and preferred shape parameter is probably going to be Pavel Chris's concept with the phase angle at a constant modulus, or the use of a logical index at R value. I was talking to George about this earlier on. We were having that discussion, 30-odd years ago, and now we're reinventing that one in the discussions that we're having now. Delta TC has been talked about a lot. Don't use it. It doesn't work. It's not a good parameter. That's my viewpoint, and the industry is coming out with that viewpoint as well next year in a paper. It has horrible reproducibility. So that's just something to mention there. In terms of the performance of asphalt binders, this is in the paper. We can see how the performance is compared to SBS. We have very similar performances, and really that's what we're trying to compare ourselves against in terms of how we do the modification. Another important aspect is storage stability. There's been a lot of work done with storage stability of this product. Various folks in this room have been involved in some of those studies, and we see that we have a very good storage stability.
Jeff, please.
Yeah, we're going quickly. The mix work, this has all been done in Europe. Mix design details are detailed in the paper. Normally we're looking at fatigue cracking, permanent deformation. Those are the two critical aspects. This graph is in the paper. Generally we're seeing an order of magnitude improvement in fatigue. We like to think that maybe the biggest bang for buck that you're getting is maybe around about the 10 to 15% modification level in terms of the fatigue performance, but this is very similar to what we've seen other folks. I should mention that this is using the old style of the fatigue test at 50% failure condition. If you use the new style where you go to the NE star, you get an even bigger bang for the buck. Deformation, we have seen this has been presented, by other folks. We see the reduction in rutting, and very good performance. And in terms of summary, there's a slide here just shows some of the mixing. We used a dry mixing process in the work that we presented in the paper. And in summary, this is, the extruded pellets from the devulcanization process is working very well. Typically 2 PG grades by about 8 to 10% by weight of binder. Materials are storage stable. They don't separate. The laboratory and plant trials show that it works very well, and you can use either a wet process or a dry process. And now the most important thing is that QR code. If you've got your cameras out, just snap that QR code and then you can download. Thanks very much.
Yeah, and we're available to discuss if anybody would like. We went through fast.
Yes, they are around. It's just very good. The reason I'm kind of trying my best to listen to the fantastic presentation. It's very interesting. But please remember, today we have to leave here by 6 o'clock. You must exit at 6. Get in your cars so you can see the sunset at the restaurant with the nice gin and tonic, okay? That's the important part of this meeting. So, just so you understand. So, thank you.
Thank you.
Thank you. So, next presentation is Tian. A review of chemical reagent-based surface treatments for enhancing compatibility of waste from rubber with bitumen. Thank you very much.
This is yours.
No.
This is good?
Yes.
Sorry, here. Here.
Okay, okay.
You can show. It's up to you.
Thank you. Good morning, everyone. I'm Nie Tian. I'm a second-year PhD student from the University of Bologna, and it's a great pleasure for me to stay here to share my research with you today. The presentation is titled Review on the Surface Activation of West Chrome Rubber with Chemical Reagent to Improve its Compatibility with Bitumen. This research comes from my doctoral project, which focuses on developing one kind of impact-absorbing pavement using the dry process and also the cold process recycled rubber. But because of the poor compatibility between the rubber and the bitumen during the process of producing this kind of material, it remains a major obstacle because of the poor compatibility. So during my first year, I conducted a lot of review and systematic research on this kind of surface treatment. As we will know, nowadays the tire disposal is a critical environmental risk. But normally, when we just try to solve a single problem, it would be very easy. But when we try to seek a more optimal solution, it would be quite difficult for us. Like the rubber recycling. Because we want to remove the waste, but at the same time we want to create some value. So in our pavement domain, we want to remain the overall property of the mixture, but at the same time we want to try incorporate as much as the rubber inside. So also, as we mentioned, the poor compatibility between the rubber and the bitumen, a lot of researchers just conducted different kinds of surface treatment in terms of physical and also the chemical methods. But there is also a lack of systematic classification about it. So this review just classify them into different categories. We can say they could be oxidation, acidification, and alkalization, and grafting, devulcanization, and even some other surface treatment like pre-coating and pre-swelling. But before the introduction of the surface treatment, knowing about the production, also the composition is also important. Because it can help us to know the reaction between the chemical reagent with the rubber. The production of the Western crown rubber mainly involves multiple stages like cutting, grinding, and sieving. And finally, we can get different products and also the particles of different sizes of the crown rubber. But interestingly, less than 1% of the Western crown rubber is applied into our asphalt pavement, with other fractions applying into some other domains like docks, buildings, arts, acoustic insulation, and also some wearable equipment. And for the composition, besides the natural rubber and the synthetic rubber that we already know, there are also some additives in the rubber that's used to improve the comprehensive properties of the rubber. For example, the vulcanization agents to form the cross-link, and the filler to improve the mechanical properties, the plasticizers to make it more flexible, and some other antioxidants to slow down the aging. And for the specific aim of the usage, they just choose different kind of substance. And we want to emphasize that also because of these additives, our treating and the recycling would be more and more difficult. So let's move to the surface treatments. The first method is the oxidation, and the most typical and common chemical agents are the hydrogen peroxide and also the ozone. For the hydrogen peroxide, we usually use the ferro irons to act as the catalyst. We call this kind of solution the Fenton solution, because it could strongly and significantly to improve the reaction intensity. And for ozone, as the same image shows, we know under the humid conditions, this kind of reaction could provide more uniform and effective oxidation reactions. But anyway, all of these kind of oxidation treatment could partially break the carbon bonds and then introduce some polar groups. As a result, the surface of the crown rubber would be more rougher and wettable. But it's worthy to know that this kind of treatment is different from the aging during the usage, because it just focuses on the surface activation without destroying the inner properties. And then it's about the acidification. We usually use the hydrochloric acid. As you can see, it can react with amino groups to improve also the surface polarity and also the electrostatic interactions. And for some other acid, maybe like the pyruvic acid, sometimes it also has oxidation function. So it can just directly break the double bond to introduce some other polar groups. So it's like the oxidation just now we mentioned, so a little bit different from the acid, some other acid. And then about the alkalization treatment, we want to emphasize this kind of chemical reagent, sodium hydroxide, because in addition to alter the surface property of the chrome rubber, it can also convert the metal into some soluble sodium material. So it means using this kind of chemical reagent, we can highly reduce the chemical risks from the residue metals. But we also conducted a lot of laboratory experiments about this kind of chemical reagent. We found that at a concentration above 15%, it would be very hard to remove the sodium hydroxide residue from the rubber surface. So pay attention to this. Next method is about the grafting. The purpose of this kind of method is to adhere some functional groups or even some polar chains on the surface of the rubber. And there are two different kind of methods. For the first category, we can just use some chemical reagent to directly react with the chrome rubber without any pre-treatment or pre-cleaning. So this kind of method is like the oxidation or acidification we mentioned just now, but because the active sites on with the chrome rubber is limited, so most of the researchers, they usually use the oxidation before this kind of grafting surface treatment. And as we said, they usually use the hydrogen peroxide or some initiator to create some carboxyl or hydroxyl groups on the surface of the chrome rubber, and then use some other polymers to graft onto the rubber. In this way, it can make sure more polymers could bond with the chrome rubber better. And for this kind of method, because theoretically it's not a specific surface treatment of the rubber, but we just want to emphasize that with the mild devulcanization, we can also break some bonds on the surface of the rubber and make it rougher. And also introduce some active sites for the rubber to better connect with the bitumen. And here we want to emphasize that the devulcanization and the desulfurization maybe it's a little bit different, because for the first one, we just keep the main carbon skeleton of with the chrome rubber, but the desulfurization, the main is to remove the sulfur. So maybe it will destroy the whole structure.
please.
Okay,
hurry
okay.
up.
I would be quicker. And for some other treatment, we have pre-swelling and pre-coating, but there are just the limitation of the research. So for the pre-swelling, we did some experiment in our lab, and also today I bring the sample that we made in the lab. If you are interested, you can take a closer look of it, and we can discuss it later. Because of the time, so maybe I just skip it and introduce a little bit for this kind of material. It's made of wrap and chrome rubber with emulsified bitumen. So it means the aggregate is made of almost 100% of recycled material, and we also produced it in the room temperature. And this kind of material is based off another social problem, because nowadays our sidewalk and cycling is made of hard material. So people always get injured after falling down. So with this kind of elastic material, maybe it can help to avoid this kind of social phenomenon. That's all. Thanks for your listening, and I would be more happy if you have any question.
Thank you. Time for one quick question. Not two, not three, one.
Hello. So thank you very much. Thank you very much for your presentation. One quick question: how we can check the modification grade of the bitumen with rubber and polymer? So how many polymers and how many rubbers are used in this modification bitumen? Can you maybe check, say yes? This same question I wanted to ask our Italian colleagues, so maybe you can answer me.
Okay, thanks for your question. You mean how to check the degradation of the rubber with the
polymers and rubbers in the bitumen? How I can check it?
Okay, because this is one kind of review, and I've heard there is one kind of experiment named soluble. You can check the soluble materials before and after the treatment, so you can know. Maybe it can provide some information about it, but actually it's still very difficult to know about it.
Thank you so much.
Okay,
Appreciate, great presentation. If we can have, yep. So if you can have Kaur. Advanced characterization of industrial waste modified asphalt rubber mixtures, a focus on encapsulating the activated rubber asphalt conglomerates. Hello.
Good afternoon, everyone. Myself, Harmandeep Kaur. I am a PhD scholar working under the supervision and advisory of Professor Krishna Prapurna. This is our research team. Today I'll be presenting my work, PhD work, which is related to encapsulation of asphalt rubber by incorporating industrial waste materials. So this is the presentation outline. First, let's have quick introduction to the product which we are developing, which is E-Simmer Pave, where E stands for encapsulation, then sustainable industrial materials which are utilized to modify asphalt rubber pavements. So basically in product development, first we are creating asphalt rubber using 62% of crumb rubber and around 20 to 25% of asphalt. And then we are coating it with industrial waste materials. Initially, we started with 9 different industrial waste materials which are abundantly available in India, which included fly ash, pond ash, montmorillonite, then silica fumes, then blast furnace slags, and some of the steel slags, mill scales, and so on. And then we did advanced chemical characterization for all these 9 sets of modified asphalt rubber products. And further, LCA was carried out on all these products, and ranking was generated for the set of products to come up with the best industrial waste, which was most compatible with rubber as well as asphalt. So this work is already published. We are very happy to share the link if any of you want to go through this work. And what was the motivation behind development of all these modified asphalt rubber products was, first, we all know about end-of-the-life tires. Plus, in addition to that, in India, managing industrial waste material is a big problem. Here in this image itself, you can see this is from Punjab region. In Punjab is basically agriculture dominant state of India, and there is a huge crux for electricity, and most of the electricity comes from thermal power plants, and those thermal power plants are generating tons and tons of fly ash. And there is no space for stockpiling that fly ash. So they have made these 3 big lakes in one of the city in Punjab, and they are storing 2.2 to 2.5 metric tons of fly ash in these lakes, which are in the end of the, like after 5 years or 6 years, all the materials from this fly ash is leaching and polluting the good fresh water of the Punjab region. So our motivation is to utilize these kind of waste materials into building materials, or to find a way how we can incorporate these industrial waste materials into rubberized asphalt mixtures. So in this product, in this research, we basically used the set of industrial waste materials as a stabilizer or as an activator, which will replace some portion of hydraulic lime. Like it is, this product is very similar to RARX. So in place of hydraulic lime, we are utilizing the waste materials which are having higher quantity of calcium hydroxide in their composition to replace some quantity of stabilizer. The objective of this research was to develop and characterize E-Simmer-based composite mixtures, including fly ash, pond ash, and ground granulated blast furnace slag. We actually worked on all the 3 sustainable development goals. A scope of the work included for this particular paper was to produce E-Simmer mixtures in the lab and to do characterization, advanced characterization for all these products. These were the materials which were utilized in the study. So first one, crumb rubber, we are all aware of. I will be specific that this is mesh 30 crumb rubber. then fly ash, pond ash, and GGBFS. Why only these three industrial waste materials? Because initially I talked about that we did advanced thermochemical characterization and LC of all the industrial waste products. From there we took the first three ranked industrial waste materials, which were further utilized in mixtures to develop the advanced MAR mixtures. So here you can see the e-simmer mixtures which were prepared using superpave gyratory and some of the plugs which were developed in lab. This was the design of experiments for mixture testings. And the gradation, in-house gradation, which was developed by incorporating 10% of, by replacing 10% of the fine aggregates using modified asphalt rubber product. 5.2% was the binder content which was used for developing the mixtures. And these are some of the results, interesting results which were found. Like here you can see at 37 degrees Celsius and 54.4 degrees Celsius, for conventional material, we are not even getting the values. In India, high temperature performance is more critical. Like, especially in South India, we are having pavement temperatures ranging anywhere between 16 degrees Celsius to 80 degrees Celsius. So we want that our material should perform in that temperature range. For conventional materials, we are unable to get the results at 54 degrees Celsius. But for modified mixtures, we can see still the values are in the range of 500 to 1,000 in case of modified mixtures. And overall, 27% to 44% increment was observed in e-simmer mixtures. These are the results from moisture susceptibility test, that is TSR. All the three mixtures, that is incorporating pond ash, fly ash, and for ground granulated blast furnace slag, the results were higher than 80%, which is recommended. Similarly, for flow number, you can see for pond ash modified mixtures, the values are almost 5 times than the conventional mixture. That is a very huge bump in the performance. Next, semicircular bend test was performed to test the fatigue life of the mixtures. In this case, again, we can see that pond ash modified mixtures are performing better than the conventional as well as other two industrial waste modified mixtures. Similarly, at 5 degrees Celsius temperature, again, for pond ash modified asphalt rubber mixtures, the values are almost 1.2 to 1.5 times the conventional as well as other MARs. Conclusions and recommendations from this work was that e-simmer can be integrated into the mixture using superpave, and it can even be incorporated in dense graded mixtures very similar to HMA, and durability for all the three mixtures is almost 2 to 3 times the conventional mixes, and thermal cracking and rutting performance is also better by 4 to 18% than the conventional, and even cracking for fracture toughness of the material is almost 40% more than the conventional mix. Recommendation is that e-simmer mixtures can be used in all weather conditions as they are performing better in thermal conditions at higher temperatures and also in moisture susceptibility. These are the key takeaways, that in mixture composition, almost 5% of the mix can be replaced using this new set of e-simmer product. In e-simmer composition, almost 62% is crumb rubber, 22 is asphalt binder. Here in this case, we are using softer grade of asphalt, and 8% is hydrated lime, and another 8% is industrial waste, which can be fly ash, pond ash, or GGBFS. And in almost in 1 kilometer long lane road stretch, we can incorporate 30 tons of e-simmer, out of which 18 tons will be crumb rubber and 2.4 tons of industrial waste can be incorporated in only 1 kilometer long length. And in conventional AR mixtures, which are already established, in that we see that only 1% rubber is utilized in whole mix. But if we are using this new set of products, we are able to incorporate up to 5%. At present, it is only in the lab scale, but in lab scale itself, we are able to incorporate 5% by weight of mix using this crumb rubber, modified crumb rubber products. And this whole study is based on the circular economy, that first we are also solving the issue of land filling, which is a huge crux in North India. Plus, we are enhancing the property of the mixture using crumb rubber, and we are also activating the crumb rubber using industrial waste, and we are coming up with new generation stabilizers.
Thank you.
Thank you.
We have, very good. Okay, you can ask one question. Just kidding. Any question? Really? Don't. Okay, okay. No, I'm just okay.
People need to eat, right?
Go ahead. It's okay.
Well, people need to eat. I just very quick. You said 1%, and then later on you said with this technology you can use 5%. That's 5%. That's how much rubber you are talking about?
In 5%, almost 3% in total rubber will be there. Because 62% of the product is rubber. So 62.
Thank you. Anybody else anymore? Okay. Thank you so much. Very good.
Thank you.
Last one before we go for lunch. Hernandez. Ajuda aí.
Good afternoon. Thank you so much for coming today. I am a pleasure for staying here in this incredible and amazing city. Let me know. My name is Eliseth Roa. I am from Mexico, and I am a civil engineer with a master's degree in land transport. And today I will be talking about interesting project. This project was a test section. A test section was built in Mexico City. This test section was with warmic asphalt, with crumb rubber, predigest, by predigest and activated crumb rubber. That is incredible for me because was the first test section in Mexico City. This is the content of my presentation. First, I will do an introduction, then an objective, methodology, results, and conclusions. To start, I like to mention that in Mexico, most waste tires are not recycled, only about 10% of them. This is a good opportunity for payments. It's estimated that about 40 million tires are thrown away every year in Mexico. The use of chrome rubber is a technology that has been promoted for many years. All of you know that the chrome rubber is a good technology for asphalt pavements, but we need higher temperatures for best results. However, 3 years ago, during my master's studies, we developed an interesting research with pretreated and activated tri-rubber power. Since we obtained good results on different tests, like you can see, is TSR, Hamburg World Trucking, dynamic modulus, and fatigue life, and other tests, and I know I don't mention here. So we decide we obtain a good result. We decide propose a test section. The test section was built on Circuito Azteca in Mexico City. It was 291 meters long, 10 meters wide, and 7.5 centimeters thickness. Why Mexico City? Which is Mexico City? Because the use of warmic asphalt has been mandatory there for pavements works since 2010. It's the unique city in Mexico where it's mandatory to use the warmic asphalt. The objective of this project was to evaluate the performance of a warmic asphalt that includes tri-rubber power through the semi-wet process. The semi-wet process, you know, is possible with the product RAR by building a test section of Circuito Azteca in Mexico City. The methodology included develop a laboratory design of a warmic asphalt, modified with contain 1% of the pre-digest and activated tire rubber with materials from Mexico City. When I made my research, I worked with other materials, so we needed to develop a design for Mexico City. Then plan production for the test section, check the temperature control during laying and compaction, and quality of sample from the plant. You can see in this graph, we reviewed the production temperatures, which average was 140 degrees Celsius. In this point, you can see. And we also checked the laying and compaction temperatures in the field, which average was 130 degrees Celsius. These temperatures are in the range for Mexico City. We took production samples to test in the lab. This test section was built in 2 days, so we took 2 samples, and we checked in asphalt binder content, volumetric properties like densities, air voids. For this design, we use Marshall methodology, so we also check stability and flow. In my research, I use the SuperPay methodology, but in this case, we use the Marshall methodology because it's the specification for Mexico City. For the check the chrome rubber, we use the ignition oven. The mixture evaluated in the laboratory meet the specification of Mexico City. You can see in this line the specifications. With the sample, we prepare specimens for the TSR test to evaluate the moisture damage according to ASHTO 283. Then we made 6 specimens with the mixture, and we obtained a result of 94%. That is incredible and amazing because the weather in Mexico City is raining all the time. So that test is very important. We also prepare specimens for the Hamburg wheel tracking test to evaluate the permanent deformation. The results were very good, with average root depth of 5.3 millimeters. You can see in this graph, in this table, the results. The results is good, is very, very good, because the MIG was made with performance grade C3 for asphalt and in warm temperatures. Finally, we conclude that adding 1% tire rubber to a warm asphalt improves in performance and helps to reduce the number of weight tires that cause environment pollution in Mexico City. And thank you so much for your attention. And I have a lot of information, but I will be try quickly because I think it's time to launch.
Thank you very much. Incredible. Very, very good. Questions? You can have. All right, let's go for lunch. Try to come back on time, okay? Short lunch. Thank you.